Okay, man, there we go. Like you know, I'm Joseph Gata. Welcome to my study for understanding some of the lessons of English that I'm going to teach you. So today, what you are going to study, this is a review about the thermodynamics. So this is we're going to study all the things that we studied before. But for the new, yeah, I would say the new students that came here for seeing this video, I'm going to ask them just to download an app. This app is very important. Why? Because it shows you some of the contents of the thermodynamics. So yes, it is really great. There is a lot of things that you're going to study there, and this is just based on these lessons that I'm explaining you, the lessons about the mechanical engineering. So I mean that it is important for you to download this app. This app is very rich about the I would say the knowledges of the mechanical engineering for the beginners and even for the advanced. So that depends. But for the advanced, there is some of the knowledges at which you have to pay, I would say, at premium, you know, so you have to pay just for seeing these contents, but this is not too much. And I would say, I would say that the price really is, yes, I would say it's not expensive for this type of knowledges because if you get that, it's a very advantage for you. So what we're going to study is just the thermodynamics. What is the thermodynamics? The thermodynamics is the branch of the science that study the properties of systems that have temperature and the law of the conversion of energy from one form to another, the direction in which the heat yes, the direction in which the heat will flow, and the availability of our the heat energy to do the work. Yes, so every things like that are just giving us what is the thermodynamics. So everything, almost everything in mechanical engineering is related to the thermodynamics. When you see, for example, the industrial engines, like for example the internal combustion engines, the propellers, the engines that we use the planes, because for the planes, of course, as you can understand, there is some of the engines that we use, the engines at which the I would say the energy is converted from one form to the mechanical for making rotation and for what the plane fly. And for the cars, I mean that you already know the fact of converting our fuels, it can be the diesel fuel, the gasoline fuels to the mechanical work. So this is about that. This is about everything like that. Then even the power plant. The power plant also is based on the laws of the thermodynamics. So almost everything is based on the laws of the thermodynamics at one point. Nowadays, there is some of the things that we use, for example, to convert just the electrical. Uh, so to convert the electricity to mechanical work, for example. Yes, this is not the thermodynamics. So nowadays, it is I would say it changes, and there is a lot of things that are new. But mostly, as you can understand, mostly they are based on the laws of the thermodynamics, or based on even the thermodynamics. So this is what we're gonna study. Um, we're gonna. There are some of the important terminologies that you have to know. For example, what is the mass? What is the force? What is the equilibrium, and so on and so forth. So all these terms are just related to the thermodynamics. But I mean that just through my explanations of the lessons that yes that I gave you, I mean that through that you will understand just everything. So that will be clear. So firstly, what is the specific heat at constant temperature? The specific heat at constant temperature, this is the ratio of the heat, like of the change of the enthalpy with respect of the absolute temperature when the pressure is constant. So this is a conventional unit that is equal to 1.005, uh, which is the 1.005 kilojoule per kilogram Kelvin. So this is something that you have to know, and I mean that the formula for giving that equal to the in fact, they are based on the property of the substance. So the property of the system as given, just given to the formula. So there are two terms for giving the property of the system. There is U, that is equal to 186 plus 7, 0.718 G, and the last one is P, EV. EV equals 0.287 plus G plus Kelvin. So I mean that this is something that is very important. I have some of the messages here based on the mechanical engineering lesson that I just see on Telegram. So Telegram is an app also at which you can just yes, they I would say in a group at which they are learning the mechanical engineering lesson. So this is very interesting because I learned everything there. So this is it is really great for me. So yes, and the first law of the thermodynamics, there are three laws. There are just three laws that you have to do. You have the first law, the second law, and the third law. So the first law states that the energy cannot be created or destroyed, but just converted from one form to another. And the total heat is converted into work. And this is the law of, it is also called the law of the conversion of energy or the conservation of the energy. So this is the law of conservation of the energy because of the fact that it states that the total heat is converted into mechanical work. Yes, and yes, and there is a law that I would say that avoid that, and yes, that is the contrary of this law. This is called the law, the first kind of perpetual machine. So it states that what it states, the machine which would continuously supply the mechanical work without another form is energy is a very symmetrist. So this is a law that doesn't exist because it is physically impossible. And what is the internal energy? And because I said, I just said that the internal, there's a lot of types of energy that are just inside of the system or even outside that are going outside of the system. So the sum of this type of total, of these types of energy, of all these forms of energy, is called the internal energy. So this is the sum of the potential energy, the kinetic energy, and every energy inside of the system. So yes, this energy is very yes, because you yes, because of the fact that it is related to every forms of energy. So it is also related to the heat that is just going because of the fact that when the system is working, it will always release some heat energy like that. It will release the heat at high temperature because it is working, you know. So this is also about this type of energy also. So every types of energy like that. We talk about the potential energy. When we talk about the heat energy that is used for making the piston, in our case, we talk about the combustion engine for making the piston moving, slide down for making the movement, the piston slide down or even going up. So it use the heat energy. So the heat energy, the potential energy, the kinetic energy, so everything like that of the system is called the internal energy. And it is also divided into two types of energy that we have the macroscopic energy and the microscopic energy. So the macroscopic energy, they are just the energy that you can see. I talked about the potential energy or something like that. So yes, I mean that you are what you understand. The potential energy of what? The potential energy of our system. So when you talk about the heat energy, because of the fact that the combustion of the engine which generates some of the combustion, yes, which generates some of the energy like that, we are going to talk about the potential energy or even the kinetic energy of the molecules. And at this moment, we talk about the microscopic energy. So we talk about the fact that there is some of the molecules that are moving very faster inside of the system, and they are making the piston slide up or even slide down or something like that. So yes, the molecules, the movement of these molecules is very, yes, it's very, it is in disorder, it is not in order. And this movement is also a tax of energy at all. So yes, and yes, and what again? The sign conventions for heat and work interaction. The sign convention, yes, the heat that is received by the system is considered positive, and that is the case also for the work that is done uh, by the system. So the work that is done by the system is considered also positive, and the heat that is exhausted by the system is considered as negative, and the work that is done inside of the system is considered also negative. Yes. So I mean that this is really easy to understand the sign conventions. And the similarities that we have to see between the heat and the work, this is just that the system at all possesses the energy, so the internal energy, but not the heat and the work. The heat and the work are just totally independent from the system. The system doesn't possess them. So yes, and they are part functions, and they are also boundary phenomena. Yes, so they are limited. This is about the limit. When you say boundary, you have to know that there is some limit. So it is not continuously and to the infinite. No, it is impossible. So it is important to understand. Yes, so now let's talk about the processes, the non-flow processes. Um, so you have a lot of non-flow processes, and for what you understand that in a better way, I will relate that to some examples for what you understand. So firstly, we have the constant volume process. So this is when the volume, that is a process at which the volume remains constant. So if I can give an example, um, yes, this occurs when in the combustion engine, when the volume is just expands like that. So at one time it weight remains constant. The explosion of the of yes, the explosion that occurs uh, when the piston will just make we slap up, then the air will be at a very high pressure input. Then when we have to inject some spark plug in the case of the gasoline or even another thing, then there will be an explosion. So this explosion will make the, yes, the gas just expands inside of the system, and that, and then the piston will start turning down. So this is called the this explosion. So at this moment, the volume will remain constant. And the constant pressure process. This is when the pressure will remain constant. And for the constant pressure process, yes, it is simple. In fact, this is when the piston will compress the air, you know, at a very high temperature. So when the piston will compress the air like that, it will be at a high temperature. So this is called the constant pressure process. And the constant temperature process, this is, we can take the example of the boiler. So when the boiler is making, uh, no, it is important, no. I will just take an example of the water that is heating. So the water that is heating will be at 100 degrees Celsius, but you have to know that there is a time at which the temperature will remain constant also. So this is called also the constant temperature process. And for derivative process, this is yes, it is an example for the gas and the piston. They are just sealed together. they are sealed. And for the when the gas and the piston are sealed, and the gas will expand. When the gas will expand, and the pressure, no, not the pressure will be released, of course. And I will say just that the pistons is very free to. No, this is not that. This is the constant pressure process. At the constant pressure process, this is when the gas and the piston are set together. And then when the piston is free to slow up and down after the combustion of the gas, it is at this moment we can call this process or this step the constant pressure process. Yes. And what again? Um, I'm going to also talk about the adiabatic process. Yes, the adiabatic process, it is when there is no heat transfer. I can take an example of the pneumatic tire. And when the pneumatic tire will have some of the holes, like that, when it has some holes, the pressure will be released. So the pressure will decrease. So at this moment, it will release the air, as you know, and then the temperature will increase. Yes. So at this moment, we talk about, of course, there is not heat transfer. So at this moment, we talk about the adiabatic process. For the polytropic process, this is an example is just the vapor compression cycle. Yes, at the vapor compression cycle, the mass, the temperature, the volume, and everything like that will change. So from one mass to another. So this is called the polytropic process also. And it is also the case for the variable flow process. At the variable flow process, we talk about just the variation of the temperature or the mass or something like that in the refrigeration cycle. Yes, now let's talk about the limits of the first law. About the limits of the first law, there is some of the questions that that we are just asking to ourselves about the fact that we know that the this is the conversion from one form to another, but is all the energy that is yes, that is converted into work, and in which direction is changing take place, the heat to work or the work to heat. And the last question, in which conditions the change will take place also. So for answering to these questions, there is the scientist just inventing the second law of thermodynamics. About the second law of thermodynamics, you have to know that this is the law of the enthalpy. That states that no, first you have to know that it is just divided into two forms. You have the Kelvin-Planck statement and the Clausius statement. For the Kelvin-Planck statement, the state is just that all the energy cannot be converted into work at 100%. There is always some of the heat energy that will be released through the air, that will be released through the atmosphere, of course, always. So this is a law that states that there will be always some of the error or some of the disorder like that that will make the total energy, all the total energy not being converted at 100%. And for the closure statement, it states just that it is possible to design a device that will have no effect other than uh, yes, other than the conversion of the body from the low temperature to the high temperature without any external work. Yes. So it is yes, for taking an illustration, I will talk you about the refrigeration cycle. there will be always an external work that will be occur for changing the temperature from the high to the low. Always with the yes the external work. So for example the compression or some things like that. There will be always some things like that. So it is important to know. It is the perfect example of this illustration. And you have also the Carnot cycle, the closest inequality, and the third law of the thermodynamics. For the third law, it states just that it is yes, this is the law of the entropy. So it states that for a body, um, or even for anything else like that, for any systems, there will be always the entropy. The entropy, this is the degree of disorder of the system. So there will be always an entropy in the system. Only crystal with 0 Kelvin, so with when at which the temperature is constant and when there will be also no pressure there, so only this body will have no entropy, only this one. But for the rest, you have to know that everybody has the entropy, of course. And this is also for this reason that for the system of the combustion engine, the heat energy, the total heat energy cannot be converted into work. So now let's talk about the gas laws. The gas laws, there's three gas laws. The Boyle's laws, the Gay-Lussac's laws, and the Charles law. Yes, for the Gay's law, the Boyle's law, it states just that this is the law at which we talk about the fact that the pressure and the volume are inversely proportional when the temperature is constant. Yes, for taking an example, I will talk about the fact that when I have a ball, I want to go to play basketball. So I have a ball. For what I just make sure that my ball will have enough air for what I play with that. I want to take some air. So I will go to the vulcanization or some things like that. And you have to know that for these types of things, they will release the air. But at this moment, the pressure will decrease for what will release the air. You know that, right? So then, when they will release the air like that, the pressure will decrease. And for my balloon that I have, the volume of my balloon will increase. So this is called the Boyle's law. Because when the pressure decreases, the volume increases. So at this moment, we say that they are inversely proportional. And what again? The Charles law. This is the law at which you say that the volume and the temperature are just directly proportional. So for taking an example, I will say that there is a balloon full of the helium or even the air. Then I will take some things like that that the smoker are using. So then I will put that like that. The temperature will increase on my balloon. And when the temperature increases, my balloon will just the volume of my balloon will increase also. So they are just directly proportional. And for the, of course, this is at the constant pressure, you know. So yes, and we have also the Charles law. And the Charles law, on which the Gay-Lussac law states that uh, this is the law at which the pressure and the temperature are just directly proportional. Yes. So I will say just that for taking an example, there is a spray on my deodorant that I'm taking on my perfume. So when I will take the things that the smoker are using, I'll take that like that. And yes, then when I will just put off that, the temperature of this body will increase. At this moment, the pressure inside of my spray, which is due to the pressure of the gases inside of this. The volume will be constant because it is very difficult to increase the volume of my spray because this is the iron, as you know. So yes, at this moment, the pressure and the temperature will be directly proportional. So the case laws that are combined together. At this moment, you have just a formula that you have to know by yourself. So this is not very difficult to understand. In fact, it is just about the fact of memorizing the formulas that I gave you, which is just in this app. So yes, and we combine these laws, and then you have the formula PV over NG equal A. So yes, it is very important to understand. So yes, this is the end of our lesson. I will say you just that you have to know and that you have to download our my app, this app about the mechanical engineering lesson, um, and then I mean that you will be able to understand the things. Thank you for understanding, and see you next time. Well, thank you.